Is Marjan M. Ramirez.
And I'm Christian Untalan,
For today, we will discuss about Chapter 23.
which is all about television.
For today, we will discuss about television. That TV signals occupies a significant amount of spectrum space because it contains a great deal of intelligence. The TV signal consists of the sound and the picture. The sound is the stereo, and the picture carries color information, as well as the synchronizing signals that keep the receiver in step with the transmitter. The entire TV signal occupies a channel in the spectrum with a bandwidth of 6 MHz. There are two carriers, one each for the picture and the sound. The sound carrier is the upper end of the spectrum. The audio bandwidth of the signal is 50 Hz to 15 kHz. Stereo sound is also available in TV, and the multiplexing method used to transmit two channels of sound information is virtually identical to that used in stereo transmission for FM broadcasting. The picture information is transmitted in a separate carrier located in 4.5 MHz lower in frequency than the sound carrier. The color information and picture is transmitted by way of frequency division multiplexing techniques. The FDM, or the frequency division multiplexing, is an analog multiplexing technique that combines analog signals. Signals modulate different carrier frequencies. Modulated signals are combined into a composite signal. The channel is the bandwidth which to accommodate a modulated signal. Channels can be separated by strips of unused bandwidth, GERD band, to prevent overlapping. The signals are assigned to frequencies in the VHF and UHF range. US TV stations use the frequency range between 54 and 806 MHz. Although TV is still transmitted by radio waves, most viewers get their TV signals via cable. Over 80% of US homes have cable TV that carries the over-the-air TV channels as well as the premium and specialized channel of programming. The video signal is most often generated by a TV camera, a very sophisticated electronic device that incorporates lenses and light-sensitive transducers to convert the scene or object to be viewed into an electrical signal that modulates a carrier. All visible scenes and objects are simply light that has been reflected and absorbed and then transmitted to our eyes. The camera takes light intensity and color details in a scene and converts them into electrical signal. Scanning is a technique that divides a rectangular scene into individual lines. The standard TV scene dimensions have an aspect ratio of 4:3. That is, the scene width is 4 units for every 3 units of height. To create a picture, the scene is subdivided in many fine horizontal lines called scan lines. Each line represents a very narrow portion of light variation in the scene. The greater the number of scan lines, the higher the resolution and the greater the detail that can be observed. US TV standards call for the scene to be divided into a maximum of 525 horizontal lines. The electrical signals derived from each scan line are referred to as video signal. Shades of gray are represented by some voltage level between the 0 and 1 volts, extremes represented by white and black. The resulting signal is known as the brightness or luminance signal and is usually designated by Y. When complete scanning of the scene is called a field. This produces what is known as interlace scanning. Interlace scanning is used to reduce flicker. The resolution of the TV refers to the amount of detail that can be shown. Pictures with higher resolution have excellent definition. A picture lacking details looks softer or someone out of focus. The bandwidth of the video system determines the resolution. The greater the bandwidth, the greater the amount of definition and detail. The color detail in scene is represented by dividing the light in each scan line into three separate signals, each representing one of the three primary light colors, the red, green, and the blue. The light in any scene can also be divided into its three basic color components by passing light through a red, green, and blue filters. The RNGB signals also contain the basic brightness or luminance information. The color signals must be transmitted with the luminance information in the same bandwidth allotted to the TV signal. This is done by frequency division multiplexing technique that combines the three color into I and color signals. The signals comprise different portions of the RNG and B signals. I is equal to 60% red, 28% green, and negative 32% blue. The Q is 21% red, negative 52% green, and 31% blue. The I and Q signals are called chrominance signals. The resulting signal is called the NTSC composite video signal. The signal from the antenna or the cable is connected to the tuner, which consists of an RF amplifier, mixer, and local oscillator. The tuner is used to select which TV channel is to be viewed and to convert the picture and sound carriers plus their modulation to an intermediate frequency. Most TV set tuners are packaged in sealed and shielded enclosures. The standard TV receiver IFs are 4.25 MHz for the sound and 45.75 MHz for the picture. Because the local oscillator frequency is above the frequency of incoming signals, the relationship of the picture and sound carriers is reversed at the intermediate frequencies, the picture IF being 4.5 MHz above the sound IF. The SAW filter greatly attenuates the sound IF to prevent it from getting into the video circuit. The IF signals are amplified by IC amplifiers. The video luminance signal is recovered by an AM demodulator. To recover the sound part of the TV signal, a separate sound IF and detector sections are used. The 4.5 MHz output of the sound detector is the sound IF signal and contains both the AM picture and the FM sound modulation. To display the picture on picture tube, special sweep circuits are needed to generate the voltages and currents to operate the picture tube. Sync circuits are needed to keep the sweep in step with the transmitted signal. A picture tube is a vacuum tube called a cathode ray tube. Monochrome and color picture tubes are available. The CRT used in computer video monitors works like the TV picture tube. The tube is housed in a bell-shaped glass enclosure. A filament hits a cathode emits electrons, which are attracted and accelerated by positive bias voltages on the elements in the electron gun assembly. The electron gun focuses the electrons into a very narrow beam. To produce color, the inside of the picture tube is coated with tiny red, green, and blue stripes. A metallic plate with holes for each dot trial called a shadow mask is located between the guns and the phosphor dots to ensure that the correct beam strikes the correct color dot.
Other screen displays. While most TV sets still use CRT for display, in recent years, new display methods have been brought to market, including liquid crystal displays or LCDs, plasma projection, digital light processing, and a few others. These new displays are more expensive than CRTs, but they have brought two major benefits to TV displays. Displays are flat or thin. The typical depth of the CRT is 18 to 24-inch. LCD and plasma displays are rarely more than 5-inch thick. These alternative displays can be made in such larger sizes. The maximum CRT size made today is 36-inch. Other display can be made in sizes from about 37 to 60-inch in diagonal measurement. Other screen displays. Plasma. A plasma screen is made up of many tiny cells filled with special gas. When the gas is excited by an electric signal, the gas ionizes and become a plasma that glows brightly in shades of red, blue, and green. The cells are organized to form triads and mix and blended by your eye to form the picture. LCD. Liquid crystal displays are used with special chemicals sandwiched between pieces of glass that are designed to be electrically activated so that they block light or pass light. When bright white light is placed behind the screen, the red, blue, and green sections of the screen pass the desired amount of light. Projection screens. A very bright light is passed through a smaller LCD screen and then through a lens, creating a picture from 40 to 60 inch diagonally. Digital light processing or DLP. These chips are made with microelectrochemical systems, or MEMS, which consist of thousands of tiny minor segments, each whose tilt angle is controllable. Cable TV. Cable TV, sometimes called CAT-B, is a system of delivering the TV signal to home receivers by way of a coaxial cable rather than over the air by radio wave propagation. Cable TV company objects all the available signals and programs and frequency multiplexes them on a single coaxial cable is fed on to the homes of subscribers. Cable decoder box is used to receive the cable signal, select the desired channel, and fed on the signal to the TV set. Cable TV companies collect signals and programs from many sources, multiplexes them, and distribute them to many subscribers. So the main building or facility is called the head end. The antennas receive the local TV stations and other stations plus the special cable channel signals distributed by the satellite. The cable companies use parabolic dishes to pick up the so-called premium cable channels. Cable TV companies uses many TV antennas and receivers to pick up the stations whose programming it will distribute. These signals are processed and combined or frequency multiplexed into a single cable. And the main output cable is called the trunk cable. So this is trunk cable. In older systems, it was so large, low cost, low loss coaxial cable never. Newer system use a fiber optic cable. So this is an example of the older systems. Trunk cable. Trunk cable is usually barred and extended in surrounding areas. Junction box containing amplifiers takes signals and redistribute it to smaller cables called the feeders. So this is the feeders, which go to specific areas and neighbors. From from there the signal are again rejuvenated with amplifiers and set to individual homes by coaxial cables called drops. So the overall system is referred to as hybrid cable or system or the FHC system. So this is an example of FHC system. Straight-through processing. So process in which local station signals are picked up and amplified before being multiplexed into a main cable. Amplifiers called strip amplifiers. So this is strip amplifiers and tuned to the receive channels pass the desired TV signal to the combiner. Heterodyne processing. So it translates the incoming TV signal to different frequency. The cable companies uses modules called heterodyne processors to translate the received signals to the desired channel. All signal on their final channel assignment are sent to a combiner, which is a large special purpose linear mixer. In the newest cable TV system, the audio and video are transmitted in a digital form in one or more of the regular 6 MHz bandwidth analog channels to the cable box. A video compression technique is used to make the signal fit in the available channel bandwidth. Digital modulation methods are used, mainly multi-level QAM. One of the most common methods of TV signal distribution is via satellite. So a communication satellite orbits the equator for about 22,300 miles out in space. It rotates in synchronism with the Earth and therefore appears to be stationary. The satellite is used as a radio relay station. The TV signals to be distributed is used to frequency modulate a microwave carrier and then transmitted to the satellite. The path from the Earth to the satellite is called uplink. The satellite translates the signal to another frequency, so this is the uplink, and it transmits the signal to another frequency back to Earth, which is called downlink. A receive site such as a cable company or individual consumer picks up the signal. Satellites are widely used by the TV networks, the premium channel companies, and the cable TV industries for distributing their signals nationally. With direct broadcast satellite or DBS TV, the system is designed for consumer reception directly from the satellite. The new DBS system features digitally encoded video and audio signals, which makes transmission and reception more reliable and provide outstanding picture and sound quality. By using higher frequency microwaves, higher power satellite transporters, and very low noise GAS FETs in the receivers, the customer's satellite dish can be made very small. The new DVS system uses compressed digital video to lower the data rate and improve reliability of transmission. Once the video signals have been put into a digital form, they are processed by DSP circuits. The DVS satellites uses the band Ku band with a frequency range of 11 to 14 GHz. So this is sample of Ku band. The advantage of using the Ku band is that the receiving antennas may be smaller for a given amount of gain. The biggest problem is the increased attenuation of the downlink signal caused by the rain. Any type of weather involving the rain or water vapor can seriously reduce the received signal because the wavelength of Ku band signals is near the water of vapor. Therefore, the water vapor absorbs the signal. The digital signal is transmitted from the satellite to the receiving using circular polarization. So digital TV, also known as high definition TV or HDTV, was designed to replace the National Television Standards Committee or NTSC system. The goal of the HDTV is to greatly improve the picture and sound quality. The HDTV system is an extremely complex collection of digital communication and computer techniques. HDTV uses the scanning concept to present a picture on HD CRT. The HDTV screen is made up of thousands of tiny dots of light called the pixels. The greater the number of the pixels on the screen, the greater the resolution, and the finer the detail that can be represented. HDTV also uses progressive line scanning, in which each line is scanned one at a time from top to bottom. In HDTV, both the video and the audio signals must be digitized by A to D converters and transmitted serially to the receiver. Because of very high frequency of video signals, special techniques must be used to transmit the video signals over standard 6 MHz bandwidth to TV channel. Multiplexing techniques must be used because both video and audio must be transmitted over the same channel.